Trigonometric Identities, Lesson 1, Reciprocal, Quotient, and Pythagorean Identities. In this unit, we're going to be dealing with all the trigonometric ratios that we've learned so far and using different identities and formulas to solve for and evaluate problems. So some tools that you want to have for this unit, you want to include your formula sheet, keep it out and beside you. It's got all the formulas we need for this unit on the left-hand side. Don't be overwhelmed. They're pretty straightforward once you understand how to use them, but all the way down the left-hand side we're going to be utilizing in this section. And the other tool you want to have with you as you work through this is your unit circle. So go back to unit 3 and pull out your unit circle. If you don't have one, please let me know. I'll get you a new copy. This unit, you're going into it with some good knowledge already. And that is, you know the 3 basic trigonometric ratios, sine, cosine, and tangent. You know their reciprocal identities. Cosecant is equal to 1 over sine, secant is equal to 1 over cos, and cotan is equal to 1 over tangent. And then we have 2 quotient or dividing identities, which is tan x equals sine x over cos x, or cotan, which is of course the inverse of that, is equal to cos x over sine x. So what we're going to be doing is using these tools to help us solve equations. In the first section, non-permissible values of trig equations and checking the equation with angle values. If you remember throughout the course, we've dealt with non-permissible values. You could also call them asymptotes. It's what the function or equation cannot equal. You would get an asymptote at that point. So for this formula, secant theta is equal to tan theta over sine theta. We kind of just want to break it down into the parts and see what are the things that theta cannot be equal to so that we have our undefined values. Now, if you look at secant theta, you need to remember that that's equivalent to 1 over cos of theta or cos x. I'll just change that to theta so we're consistent. Secant theta is equal to 1 over cos theta, and we know that cos theta cannot equal 0 because it's on the bottom of a fraction. And cos theta is equal to 0 at intervals of pi over 2 plus pi n, where n is any integer. So 90, 270, etc., all the way around the unit circle. On the right-hand side, we have tan theta on top, sine over cos. We, of course, already know that cos theta cannot equal 0. And then we just want to define where sine is undefined. So sine theta cannot equal 0. And, of course, that happens when the y value is equal to 0. And that's at pi, all multiples of pi. So pi n, where n is any integer. Now that we know those are our non-permissible values, we can take some information and plug it into the formula and solve to see what the value actually is. So there's 2 examples here. You can just pause the video and copy the examples down, but basically you're just proving left-hand side versus right-hand side. So on the left-hand side, we have secant 60 degrees, which of course is equal to 1 over cos of 60, or 1 over 1/2. So you would go to your unit circle, look at what the x value is, because that represents the cosine value, and it will tell you 1/2. It's right here if you forget. 60 degrees, 1/2. Remember, cosine, sine, and then the ratio of them would be tangent. So when you have a fraction, 1 over 1 dividing another fraction, 1 over 2, you flip and multiply, and the result of that is 2. On the right-hand side, we have sine 60 over cos 60 divided by sine 60. So we get root 3 over 2 divided by 1/2 divided by root 3 over 2. So we did the flip and multiply here. That leaves us with root 3 over root 3 over 2, and then you need to flip it again and multiply, and that will of course leave you with a result of 2. So 2 equals 2, you can say that that statement is true. The same thing for pi over 4. Just prove it down the left-hand side, prove it down the right-hand side. As long as they're equal, you know that you did it properly. Once we're familiar with the trigonometric identities, we can use them to simplify expressions. So while this problem might seem kind of daunting to solve, we can just work it down step by step. I really encourage patience in this unit and just using a good thought process about what each trig identity represents. So for example, we know that cotan theta is equal to cos x over sine x. So you're kind of just breaking it down and simplifying it as you go. Now, we need to look at this part first and make sure that we know what values these identities are undefined at. Cotan x is undefined at intervals of pi n, as is secant x. Cosecant x is on the bottom times cos x, so this whole term also cannot equal 0. Now there are no values for cosecant x that equal 0, but for cos x, that happens again at our pi over 2 intervals. So these are all our undefined values, pi and pi over 2. Once we know that, we can take the expression and simplify it down. So all you're doing is breaking it down into parts and getting it as simple as possible. On top we have cotan x, that's equal to cos x over sine x. On the bottom we have cosecant x. So whenever you see these reciprocal functions, you want to write them out in their basic trig functions. That will be the easiest way to start. 1 over sine x times cos x. So of course this cos x will just multiply there. Now we have cos x over sine x divided by cos x over sine x. So flip the bottom fraction and multiply. And of course, this all cancels out to 1. In part C, use the Pythagorean identity. I just wanted to remind you of knowledge you already have. We know that x squared plus y squared equals 1 squared, or cos squared theta plus sine squared theta equals 1. So don't forget that these corresponding points on that unit circle, no matter where the point is, the radius will always be 1. And this provides you with some different forms of proofs that you'll see later in the unit. But keep in mind this is what we're working on when we're using the unit circle. We're always having that radius 1, and then you have your x and y coordinates, which make up your cos and sine theta. In part A, you're just asked to verify that this statement is true when x equals pi over 6. So you just take this pi over 6 value and plug it in wherever there's an x, and then you just solve it out. Use your unit circle, find the coordinates, and just simplify it as much as possible. If you break this down, you end up getting 4 equals 4, and therefore we know that this statement is true when pi over 6 is our value of x. Alternatively, you can also use quotient identities to express the Pythagorean identity. So we're just looking to equate cos squared x plus sine squared x equals 1 to cotan squared x plus 1 equals cosecant squared x. There's a simple explanation here. If you see on the right, it says y multiply both sides by 1 over sine squared x. I think that this is the easiest way to pull out a common denominator. Now we know that cotan is equal to cos over sine because tan is equal to sine over cos. So if we're looking to create this part of the identity, cotan squared x, then we need a sine squared x on the bottom. So from this original identity, we're just multiplying all terms by 1 over sine squared x. Don't forget when you're moving across the equal sign, it's like a wall, and whatever you do to one side, you must do to the other. So apply your changes to all terms and really take that extra second to write this out because it will be very clear where all your canceling happens. So of course in this step, these two sine squared x's get left behind because they divide out to 1. You're just left with 1. And then we have our cos squared x over sine squared x, which equals cotangent squared x. And on the right-hand side, we're multiplying it by that original 1, and we get 1 over sine squared x, which is cosecant squared x. So this one and this one are equal, and you've proved it. The Pythagorean identity can be written in 3 different ways, and they're listed here. It's cos squared theta plus sine squared theta equals 1. Cotan squared theta plus 1 equals cosecant squared theta, and 1 plus tan squared theta equals secant squared theta. Those 3 statements are on your formula sheet. They're right here on the top left. You need to know the basic identities. You can't get by without knowing sine, cos, tan, and then their inverses. Beyond this, you have some practice questions that you can complete.